Good morning, everyone. Let us discuss about the decision tree algorithm. In the previous session, we have seen what is the decision tree and what is its representation and what are the various algorithms to solve this decision tree. Okay, so now let us discuss about the basic algorithm, which is ID3. Its full form is iterative dichotomizer 3. You know the meaning of dichotomy, 2. It stands for 2, that is a Boolean classification. Okay, so this is going to generate us a multi-way tree and it is working based on information gain. A decision tree can be generated or solved based on information gain or Gini index. This ID3 algorithm is working based on the information gain and it is taking the categorical features as input. So in order to work with the decision tree algorithm, we should know about entropy and information gain. So information gain measures the expected reduction in entropy. Okay. So first let us know what is entropy and come back here. Entropy measures the homogeneity of examples or characterizes the purity of an arbitrary collection of examples. Okay. So given a set of examples, how many are homogeneous, how many are non-homogeneous is decided by this entropy. So the formula for entropy is this one, minus probability of positive examples multiplied with log base 2 probability of the positive examples minus probability of negative examples multiplied with log base 2 value of probability of negative examples. And here if you see the graph, the entropy is ranging between 0 to 1. Okay, so that is if you have purely positive examples or if you have purely negative examples. Okay, so then entropy value can be treated as 0. You need not calculate using the formula. Directly you can take the value of 0. Okay. So why you should take 0? Because if you calculate the probability, so there P of, let us suppose that the number of examples are only 4. Okay. So then number of positive examples are 4 divided by the total number of examples are also 4. What will be the log value of this? This becomes log 1. So log 1 value is always 0. So only if you have only positive examples or only negative examples, the entropy value is 0. Similarly, if you have equal number of positive and equal number of negative examples, then the entropy value is 1. So because you have equal number of positive as well as equal number of negative examples. Okay, so you just remember these values. You need not calculate in these cases. In other values, we will be calculating the entropy using this formula. So now coming back to the information gain. Information gain measures the expected reduction in the entropy. Okay, so entropy of S minus sigma mod SV divided by mod S multiplied with entropy of SV. Okay, so here V is belonging to values of A. So here we are calculating the entropy information gain of the entire data set indicated with letter capital S against one attribute A. Okay, so this attribute might contain different values. Let us suppose that this attribute A is containing 3 different values. Okay, so now your V belongs to V1, V2 and V3. For all these 3 values, you have to find out this and then you sum it. You know the meaning of sigma, right? So for V1 also, you have to calculate mod SV1 by mod S multiplied with entropy of SV1. Similarly for V2, similarly for V3. So now let us calculate the entropy for this data set. So here the data set that we are taking is the play tennis data set, which is containing 14 examples, day 1 to day 14. So on that, what is the value of outlook, temperature, humidity and wind, and finally what is the outcome. So here the play tennis is the target variable. And here if you see, the values that you have in this column are either NS or no. Only two values you have. So only dichotomizer. Okay. So two values only it is giving. Binary classification it is doing. Okay. And the process we will be doing repeatedly. So what is the process that we will be repeating? You can see shortly. And here this play tennis is the target variable or the target value. And if you observe other five attributes: day, outlook, temperature, humidity, and wind. So in this, the day, it is simply giving us only the serial number. So day 1, day 2, day 3, so on up to day 14. So it is not giving us any provenance information. So we are not considering this day. You need not consider. Okay. So the other attributes we are taking as A. Okay. So what we have in A now? So we have outlook, temperature, humidity, and wind. For all these A's, we have to calculate the information gain or simply gain. Okay, so that means you have to calculate the information gain of S comma outlook, information gain of S comma temperature, information gain of S comma humidity, information gain of S comma wind. So here S is the name of the data set. I didn't name this data set. If you have given some name as play tennis, then you can replace that this S with play tennis. No issue. Okay. So now I should calculate the gain of all these four attributes. Why should I calculate? In order to decide the root node. Out of these four, I'm going to construct a tree with these attributes. So I need a root node. So what should be the root node is decided by the information gain. Whichever gain value is maximum out of these four, that is considered as the root. Okay, so for this, we should calculate the information gain. So in order to calculate the gain, this is the formula that we have seen. Gain is entropy of S minus sigma mod SV by S multiplied with entropy of SV. Okay, so let us do this for the first parameter, that is gain of S comma outlook. Let us do. Okay, so now what are the values under outlook? Let us see. The possible attribute values are sunny, overcast, and rain. So these are the possible values if you observe this entire column. Now our V belongs to sunny, rain, and overcast. So we have to calculate the entropy value for all these three. Entropy of sunny we should calculate, entropy of rain I should calculate, entropy of overcast also we should calculate. Okay, so before to that, let us calculate entropy of S. So here is the formula. And if you observe, you have 9 positive examples and 5 negative examples. All the S's are the positive examples. All no's are the negative examples. Okay. So like that, I have 9 positive examples and 5 negative examples. Now let us calculate the entropy. It is, 1 second, let me change my ink color. So meanwhile, I hope all of you are ready for the calculation. So those who are working with scientific calculator, directly you will have you can get the value of log base 2. If anybody are working with the system calculator or the mobile calculator or a normal pocket calculator, so then the value there you will be obtaining is a log base 10 value, not log base 2. So what you should do is divide the value that you obtained with log 2. Okay. Just get the value of log 2 and divide whatever value you have obtained with log 2, then that is the value of log base 2. Okay. Otherwise, you can just Google for log base 2 calculator. Log base 2 calculator. I want all of you to work. So let it be any of the way. Either if you have a scientific calculator, work with that, or traditional calculator also fine. Otherwise, work with this log base 2 calculator. Now, let us calculate the value p plus. the probability of positive examples. Positive examples are 9 and the overall examples are 14. 9 by 14 multiplied with log base 2 p plus, that is 9 by 14 minus p negative. The number of examples, negative examples are 5 divided by the overall examples, those are 14, log base 2 5 by 14. If you simplify this, you will be getting a value of 0.940. Okay. We have calculated the entropy of S. Next, let us calculate the entropy of sunny, rain, and overcast. So before doing that, let us see how many examples do we have under, that is, let us get the cardinality of S sunny. Under S sunny, so here I just made a color differentiation so that it will be easy for you. Okay, out of, in sunny totally we have 5 examples. In that, negative examples 1, 2, 3 negative examples we have, and 2 positive examples we have. Okay, cardinality is 5. Out of that, 2 positive examples and 3 negative examples we have. So now let us calculate the entropy. Entropy of the sun. The formula is the same, which is given as minus P positive. So number of positive examples are 2. Under S sunny only we are talking about. And a total of cardinality is 5. So total examples are 5. 2 by 5 multiplied with log base 2, 2 by 5 minus negative examples are 3, 3 by 5 log base 2, 3 by 5. If you simplify this, you will be getting a value of 0.971. Okay, so we have calculated the entropy of S sunny. Similarly, we should calculate the entropy of overcast and also rain. Okay, so let us get the cardinality of S overcast. Cardinality of overcast. How many examples do we have under overcast? 1, 2, 3, and 4 we have. And if you see the outcomes of this, 1, 2, all are positive. Okay, so the cardinality of this is 4, and you have 4 positive examples and 0 negative examples. Okay, so whenever we have either only positive or only negative, what will be the entropy value? It is 0, right? Yes. So entropy of overcast is 0. Similarly, let us calculate the entropy of rain. So before doing that, let us get the cardinality. Mod is rain. The number of examples under rain. We have totally 5 examples. So cardinality is 5. Then number of positive 1, 2, 3. Okay, so 3 positive and 2 negative. 3 positive examples and 2 negative examples we have. Okay. So entropy value will be entropy of S rain is equivalent to minus 3 by 5 log base 2, 3 by 5 minus 2 by 5 log base 2, 2 by 5. We have just calculated this value. It is 0.971. 0.971. What is cardinality of S? The total number of examples. Those are 14. In the entire data set, total number of examples are 14. Okay, so with these values, let us calculate the information gain. So here I have given the information gain of Outlook. Okay, so these are the entropy values that we have obtained, and we are just substituting that in the gain. So, okay, that is entropy of S, which is 0.940 minus mod SV, cardinality of Sunny, that is number of examples are 5 divided by cardinality of S, 14, multiplied with entropy, that is 0.971 minus 4 by 14. Mod SV of overcast is 4. 4 examples we have, all are positive. So 4 by 14 multiplied with 0 minus 5 by 14 multiplied with 0.0971. So if you simplify this, we are getting a value of 0.247. Sorry, here the value is not 0.0971, it is 0.971. Okay, if you simplify, you are getting a gain value of 0.247. Similarly, I have just given the values of temperature. You take it as an exercise and calculate yourself and cross verify with my answers. Okay, so temperature has possible values as hot, mild, and cold. Hot has 2 positive and 2 negative examples, equal number of positive and negative. You need not calculate the entropy, take it as 1. Then for mild, 4 positive examples we have, 2 negative examples we have. Its entropy value is 0.911. In cold, you have 3 positive examples and 1 negative example. Its entropy is 0.811. Okay. Now, to calculate the gain value, okay, entropy of S, which is 0.940 minus cardinality of heart, 2 plus 2, 4. The overall number of examples are 14 multiplied with 1 minus 4 positive and 2 negative, overall 6. Cardinality of mild is 6. 6 divided by total number of examples 14 multiplied with the cardinality 0.911 minus, here cold has 3 positive and 1 negative example, total of 4. Cardinality of cold is 4. 4 by total number of examples are 14 multiplied with 0.811. If you simplify, you are getting a gain value of 0.029. Next, similarly, I have calculated the value of humidity and wind too. Okay, so it is the same procedure. Just cross verify with my answers. Okay, so gain of S comma humidity is 0.151. Gain of S comma wind is 0.048. So now, if you, this is the algorithm we are verifying with. So what we have to do, first of all, we have to create a root node. Okay, so here all examples are not positive, all examples are not negative, and it is even not empty. So what we are doing, so we are taking the attribute which is best classifying. So for this best classification only, we are taking the help of information gain. So now whichever attribute has given us a better value of information gain, that will be taken as the root node. Let us do that. So if you see 0.247, 0.029, 0.151, 0.048. Out of this, 0.247 is the maximum value. 0.247 is the maximum value. So we are taking Outlook as the root node. We have taken Outlook as the root node. And here I have mentioned the examples also. We have taken all the examples of the set S, D1 from D1, D2, so on up to D14. In this, we have 9 positive and 5 negative examples. And its path. Here, each node is a test, right? So we have performed the test. What is the test that we perform? Calculating the value of information gain. and Outlook has got the maximum value. So this became the root node. Now coming to its path. Okay. So here each path will have the various values of this attribute. So this attribute has possible values as sunny, overcast, and rain, right? And then these are the examples from which we have 2 positive and 3 negative examples, and overcast 4 positive and 0 negative examples, rain 3 positive and 2 negative examples. And these are the examples that we have considered. Okay. So now if you see, overcast has 4 positive examples and all are positive examples. So that means directly I can label it as yes. I need not solve it further. Okay. So directly I got my classification. At the leaf node, I can write a value yes. So this path is solved. I need not solve for this path. So now I have 2 more alternatives. Should I go with sunny or should I go with the attribute value rain? Okay. So which will give me the best value? That should be checked out. So let us just go back to the algorithm one step. Okay. For each possible value vi of a, add a new tree branch below root. That is what we did. With all possible values of a, we have added the branches. And now example vi be the subset of examples that have value vi. So now the partitioning has started. Out of the entire set of examples, now I am starting the partitioning. What are the possible values? Sunny, overcast, and rain. In that, overcast is solved. So I got 2 more values, that is sunny and rain. So now I should split the entire set of examples. With this sunny, we will make a separate table, and with the attribute value rain, we will take and one more table. Okay. And once again, we call this algorithm. Let's do that. So this is our example, right? So in that, overcast is done. So now I whether to choose sunny or whether to choose rainy. So that means which node should be expanded next. To take the decision, what we are doing is we are partitioning this table and making a separate table. So here, these are the attributes these are the examples we have considered: D1, D2, D8, D9, and D11. And I just copied the values here. And now once again, we have to calculate the information gain and the entropy value. So now treat this as a separate data set. On this data set, once again, we have to calculate, we have to repeat the same process what we did for the actual table. Got it? Similarly, we should repeat this for the. Now let us calculate the entropy of SNE. The subset of the examples have become another data set for us now. So now here, if you observe how many positive and how many negative do we have? 1 second, let me change the ink color. So if you observe, you have two positive and 3 negative examples in SNE. Okay. So you just have 2 positive and 3 negative examples. So minus 2 by 5 log base 2 by 5 minus 3 by 5 log base 2 by 5. Its value is 0.971, which we just computed. Okay. So now, similarly, I should compute the information gain for all the 3 parameters again. Okay. So now I'm not considering Outlook because I got a solution for Outlook. I need not solve that path again. So if you see, among the 4 attributes values A that we had earlier, now Outlook is removed and only temperature, humidity, and only 3 attributes, 3 A's are there. So now I should calculate gain of S comma A. So here what is S? S is S sunny. So that means I should calculate gain of is sunny, and the first attribute, that is temperature. I should calculate the gain for this. So which is entropy of S sunny minus of cardinality of. So what are the possible values for temperature? So in temperature we have hot, mild, and cool. Three possible values we have. Okay. So mod S of S hot, cardinality of S hot divided by cardinality of S multiplied with entropy of S hot minus cardinality of S mild divided by cardinality of S multiplied with entropy of S mild minus one more value is hot, sorry, cold. S cold divided by what is multiplied with entropy of S cold. So that means I should calculate the entropy of S hot, S mild, and S cold again. Let's calculate that first and substitute it here. Okay, in order to calculate entropy of S hot, the number of positive examples that we have are 0 and number of negative examples under this are 2. So here you can just check. Under hot, you have 2 negative examples with nose. Only 2 negative examples we have, no positive examples. So what will be the entropy of this? Ultimately, it is 0. Similarly, entropy of S mild we should calculate. We have under mild, you have 1 negative example and 1 positive example. S is positive, no is negative. 1 positive and 1 negative we have. So what will be the entropy? Value is 1 because we have equal number of positive and negative examples. Similarly, entropy of S core, we have only one with score, that too it is a positive one. So I have only positive example. So its entropy value will become 0. Now let us substitute this in the gain formula. That is entropy of S sunny, which is 0.971 minus cardinality of S hot divided by cardinality of S hot is 2 divided by, here this S is S sunny. That is the difference between the actual data set and here. S sunny, the number of examples under S sunny are 5. So 2 by 5 multiplied with 0 minus S mild. The number of examples under S mild are 2 divided by the number of examples under S sunny, 5 multiplied with 1 minus S cold. So we have only one example and S sunny value is 5. Cardinality of S sunny is 5 multiplied with the entropy, which is 0. So if you simplify this, you will be getting a value of S sunny comma temperature is 0.570. Similarly, we should calculate for S sunny comma humidity, the next parameter, and similarly we should calculate the gain of S sunny comma wind too. Let's do that. We are calculating the information gain of S sunny information gain of S sunny comma humidity. Okay, so what will be the positive values? What are the possible values under humidity? We have high and normal, two values, right? V belongs to high and V belongs to normal. So let us calculate the entropy of these two first. Entropy of S high. Okay. Under high, we have all three negative examples. All the three are 0 positive and 3 negative examples we have. So ultimately its entropy value is 0 and entropy of normal, entropy of is normal. With normal, we have two positive examples, two positive examples and 0 negative examples. Once again, what will be its entropy? Entropy value is 0. So that means if you substitute in the gain formula, it is entropy of S minus entropy of S sunny minus sigma mod SV by S. Here S is S sunny multiplied with entropy of SV. In exam, you should write all these formulas as well. So here V is belonging to high comma normal. So anyhow, this value is becoming 0. So if you substitute, it is 0.971 minus 0. So the value remains the same. It is 0.971. Similarly, we should calculate the information gain for wind too. Let us do that. Gain of sunny comma wind is entropy of sunny minus wind has weak and strong, two possible values. So minus S weak cardinality of S weak divided by cardinality of S sunny multiplied with entropy of S weak. Entropy of minus cardinality of S strong divided by cardinality of S sunny multiplied with entropy of S sunny. Multiplied with cardinal entropy of S strong. Okay, so if you calculate the entropy of S sunny, entropy of S weak and S strong, just calculate the values and directly we will substitute those values. I'm just trying to show you all possible ways of doing this, okay, so that you can solve. Let us just calculate the values. I hope all of you have calculated, and here I'm giving you the values of it. Okay, so now if you see the entropy of S weak, it is one positive and two negative examples. So here under weak, we have one no, second no, yes, two negative examples we have and one positive example we have. Okay, one positive and two negative. So here is the computation of entropy. which will give us a value of 0.918. So we computed to 0.918. Okay. Next, under strong, we have one positive and one negative example. Its entropy is 1. So if you substitute all these values here, 0.97 minus, okay, the third digit I just ignored, 0.918 minus 1. Okay. So if you simplify this, I'll just have the summary here. So gain of S sunny comma humidity is 0.970. Gain of S sunny comma temperature is 0.51. I think there is a slight modification in the third digit. Don't worry. When you compute, you will get the correct value. S sunny comma wind is 0.019. So now out of these three, the maximum value of the gain is 0.97. So now humidity is selected as the next root node. Okay. So whichever variable or whichever attribute is giving us a higher value of gain, that is taken as the next attribute, considered as the next root node. So now here we are considering humidity as the next root node, and these are the examples that we have taken. And if you see under humidity, what are the possible values? Just let us go back and see. Under humidity, the possible values are high and normal. Okay. And if you observe, all highs have a negative value and all normals have positive value. I hope you're getting here. If you observe, all the high has a negative value and all normals have a positive value. So I can name the leaf nodes. I can label the leaf nodes. So humidity has two possible values. So finally, I'm able to label it as no and yes. Okay. So I reached to one part. Next, similarly, we have to compute for the rain also. You have to follow the same procedure. And these are the data sets we are considering. So with this, we will construct a separate table. From these example, once again, we will take only D4, D5, D6, D10 and D40. And let's make a separate table. And now, once again, calculate the gain value for temperature, humidity, and wind again. So, but now we have to consider, in order to calculate the gain, we have to consider S as S rain. Okay. S rain comma temperature. Gain of S rain comma humidity, and gain of S rain comma wind you have to calculate. After calculating this, whichever is giving us a maximum value, that we will be considering as the next attribute for the root node. So here is the computation of gain of S rain comma temperature. Okay. So which is entropy of S rain minus S mild by cardinality of S rain multiplied with entropy of S mild minus cardinality of S cold divided by cardinality of S rain. So because here we are having only two values, there is no hot here, only mild and cold is there in this subset of examples. Okay. Multiplied with entropy of S rain. I have calculated the entropy also here. You just cross verify. And if you substitute, you are getting a value of 0.0192. Similarly, we have to calculate the gain of S rain comma humidity. Okay. So this is the value of strain comma humidity. Finally, here also we have obtained a value of 0.0192. So this is the value we have obtained. Next, we have to calculate the gain of strain comma wind. Okay. So the same data set we are considering for wind. Here the possible values are weak and strong. Okay. So weak, 2 positive, all 3 are positive. In strong, all 2 are negative. Okay. So we are getting the entropy values as 0. And if you substitute back this in the formula, we are getting the gain value of 0.97. So here I have just listed the gain values of all the 3 attributes. Okay. So here we have 0.97, which is high, that we obtained for the attribute wind. Okay. So now this will be considered as the next node, next root node. Okay. So this is the final decision tree we have obtained. Okay. So wind has 2 possible values, strong and weak. Okay, all strong has values no, and all weak have values yes. If you see this, all the wind is the deciding parameter. So wind has only 2 possible values, weak and strong. Weak 1, 2, and 3. All the 3 weak are S positive. From D4, D5, and D10, we can say S. And from D6 and D14, we can say it as no. So this is what we have mentioned here. So here I have labeled the example number also. You can just cross verify. And this is the final decision tree that we have obtained. So this is how ID3 is going to work. Hope you followed. If you have any queries, please post it in the comment section. Thank you.